Today we're looking at area of a parallelogram. Okay, so what's the area of the following parallelogram? Well, firstly, wouldn't it help to find out or think about what a parallelogram actually is? The way I think about them is a rectangle, which has the property that all of these angles are the same, which is 90 degrees. That side is parallel to that, these lines never meet, and these sides are parallel to each other, okay, i.e. they never meet. And a rectangle has the property such that these two sides are of different length. If they're the same length, then it's a special kind of rectangle, a square. All right, so what would happen if I push over this rectangle? I came along and gave it a little nudge with my hip or with my hand, I just push it over. What we get is this, a parallelogram. So a parallelogram in my mind is just a pushed over rectangle. So what happens when I push it over is these two sides still stay parallel and these two sides still stay parallel. Now what happens is the angles change, but since we haven't done geometry yet, we're not going to worry about the angles for this at this point. So how would I find the area? Well, with a rectangle, what we were doing was multiplying the values here together. Okay, so if this was 5 and this was 15, we'd multiply 5 by 15 to get the area. So wouldn't it be 7 times 12 equals 84 meters squared? No. Okay, that is actually not correct for a parallelogram. Would I just add the side lengths together? No, that's going to give me the perimeter. And in fact, the correct answer to this particular problem is there's not enough information to obtain area. Let's go back and reflect on how we were calculating the area of a rectangle. We were doing the base times the perpendicular height. Remember, the height runs at right angles to the base. Now over here, if this is our base, which let's say that that's 12, not let's say it is 12, what is the height? See this measurement here? This is actually the side length. It is not the height. The height of a shape runs at right angles to the base. So if this is the base, I need a line down here to tell me what the height is. Okay, and since I don't know what the actual height is, there's not enough information to obtain the area. So even though you were given this measurement here, that doesn't tell you enough information about what the height of the parallelogram is to calculate the area. So to conclude, the area of a parallelogram is found by multiplying the base of the parallelogram by the perpendicular height of the parallelogram. Does the process look familiar? Well, yeah, it's the same as the area of a rectangle. Now find the area of the following parallelogram. So this is the same parallelogram, but it's got a bit of extra information here. It's got a line here that says, if this is the base, 12 meters, then this is the height. Okay, so I'm going to go area equals 12 times 6, area equals, 72 meters squared. Now, why is it the exact same process as finding the area of a rectangle? Well, I'm just going to pause this and load up a video. Okay, so here's the video. So we've got a parallelogram there with width and height. Now notice that the person picks up a chopped off point and reconnects it to make a rectangle. Okay, so every parallelogram can be turned into a rectangle. Now, how would I do that with this one? Quite simple, really. All I would do is grab that bit there, chop it off, and place it there. Okay, so that would still be 7, but the height would be 6. Okay, and so we've just got a rectangle here. So again, I'll grab a different color to try and emphasize this. Let's go fluoro green and draw a line. So this is my rectangle. Oh, it's red, I don't know why. So once I remove that bit, I've simply got a rectangle that's going to be 12 meters by 6 meters, which is 72 meters squared. All right, let's try it out on a couple of examples. So find the area of the following parallelograms. So remember, area equals the base by the perpendicular height. Base by perpendicular height. So this involves just multiplying these two values together, which is 60 meters squared. Find the area of the following parallelogram. So remember, area of a parallelogram is the base multiplied by the perpendicular height. Now, where is my base? So if I take this as my base, I need a height measurement here. And they don't give me one, unfortunately. Okay, so this one here, what I want you to try and do is turn your head while you're looking at this. Okay, so turn or tilt your head to the left. And note that if I look at the parallelogram with this as its base, I need the perpendicular height. That would be this measurement here, or this measurement here, or this measurement here. This is actually the height. Okay, so the base of my parallelogram, I'm going to consider it as 2. Okay, and my height is this height here or this height here. It's the measurement at right angles, and really there should be a right angle there saying that it is at right angles to the base, is going to be 3, which is equal to 6 centimeters squared. Right, the final example is this one here. So find the area of the following parallelogram. So we've got area equals the base times the perpendicular height. All right, now if this is the base, then the height will run perpendicular to the base at right angles too. And notice that there's no measurement for that one. It's not included. Okay, so in fact, let's treat this measurement here as the base, which means the height will be this. It'll run perpendicular to the base. Now, it just so happens that they give you that one there. So this question here is going to be area equals 40 multiplied by 15. Okay, area equals. Let's do 15 times 4 times 10. 15 times 4 is 60 times 10. That equals 600. So the area is 600 centimeters squared. Okay, so check the work plan for today and complete the exercises on area of a parallelogram.